A projectile is a particle which is given an initial velocity and then moves freely under gravity. So let's say we have our axis here, the horizontal and the vertical axis, and we project a particle with an initial velocity which is u, and at an angle of alpha with the horizontal. Then the object is going to travel along a parabolic path. We need to resolve this initial velocity into a horizontal component, which is u sub x, and a vertical component, which is u sub y. So we have our y and the x axis over here. Then this is the maximum height. Y max is the maximum height or the greatest height that the object can attain. And the range is the horizontal distance traveled along OA, and the time taken for the object to travel along the path OA is called the time of flight. Now we need to take note of certain relations that we can prove. The time of flight is given by t is equal to 2 times the initial velocity u, sine alpha, which is the angle of projection, then over g, and the g is the gravity due to acceleration. Then we also have the range given by u squared sine 2 alpha over g, and we know that this is at maximum since the range of the sine function is 1, so the maximum is 1. So when this is equal to 1, then the range will be at maximum, and that will give us R max to be equal to u squared over g. Then we have that the horizontal distance, horizontal distance is equal to u cos alpha t, u cos alpha times t. Then the vertical distance is given by y equal u sine alpha t minus half gt squared. Then also we need to take note of the greatest height, which is the y maximum, to be equal to u squared sine square alpha over 2g. Now let us see how we can use these relations to solve some WASI past questions. We have the first one here. The time of flight for a projectile motion is given by the expression. So that is what we just look at. Time of flight t is equal to 2 times the acceleration, 2 times the initial velocity, which is u sine alpha. So in this case, replace alpha with theta. So sine alpha over g. So in this case, the correct answer is C. You just replace theta with alpha. So in this case, the theta is the angle that the initial velocity u makes with the horizontal. So that is WASI 2012 for you. Now let's proceed to the next question. This one is WASI Meijin 2018. A body is projected with an initial velocity u at an angle theta to the horizontal distance. If R max is the maximum range of the projectile. What does the relation u square over R max represent? So we know that from the relation that we saw, R max is equal to u squared over g. So to get u squared over R max, we swap the g and the R max. Therefore, we have g is equal to u squared over R max. So this is telling us that this expression is standing for the acceleration due to gravity, because g is equal to u squared over R max. So that is WASI May June 2018 for you. Now let us proceed to the next question. A particle projected horizontally at 50 meters per second, so this is the initial velocity, from a height of 20 meters. Calculate the horizontal distance covered by the particle just before hitting the ground. So this is ground, this is ground. So we are supposed to take gravity due to acceleration to be equal to 10 meters per second squared. So let the horizontal distance be r. Let the horizontal distance be r, and the time that it takes to cover that distance be t. So the time is t. So t is equal to time, and we have the horizontal distance to be equal to r. Horizontal distance is equal to r. Now we know the height is given by half gt squared. So we can use this relation to determine the time that it took the particle. So we fix in the values. The height is 20 meters, so we have 20 is equal to half of g, which is 10, times time squared. So we don't know, so we just keep it like that. Now this will give us 20 is equal to half of this is 5t squared. So we solve for, divide both sides by 5 to get 20 over 5. 20 over 5 is equal to t squared. So t squared will be equal to 4. Therefore, time will be positive square root of 4, which is 2 seconds. Now we know that what we are looking for, calculate the horizontal distance, is given by r is equal to, in our case, is x. So let's use x. So the horizontal distance is x. So we were using x, so let's maintain that. X over here, x is equal to the initial velocity cos alpha, cos theta. So let's say cos theta or cos alpha, then times the time, which is t. So the time is, now we had is 2 seconds. So we substitute the initial velocity, which is 20, and because the projection is horizontal, it makes an angle of 0 degrees with the horizontal. So cos 0 times the time, which is 2. So cos 0 is 1. So we are going to get 20 times 2. Sorry, the initial velocity is not 20, it's 15 rather. So let me do the correct substitution. So this is supposed to be 15. It's supposed to be 15. So we have 15 times 2. So this will give us 15 times 1 times 2. And that will give us 30 meters. That will give us 30 meters. Therefore, the horizontal distance covered by the particle before hitting the ground is 30 meters. Now let's look at this. A ball is projected horizontally from a height with a velocity of 40 meters per second. Calculate the drop in height after traveling a horizontal distance of 30 meters. So let's see how we will go about that one. So in order to solve this, we need to first of all determine the time, like how we did in the previous one. So using the relation v is equal to d over t, as distance over time taken, we can look for the time to be equal to the swap the position to get d over v. So when we substitute, we get t to be equal to the distance, which is 30 meters over velocity, which is 40 meters per second, and that will give us 3 over 4, which is equal to 0.75. So the time taken is 0.75 seconds. 0.75 seconds. So we now use the relation h is equal to half gt squared. So we substitute to get half into bracket 10, which is acceleration due to gravity, then times 0.75 squared. 0.75 squared. So we need to simplify this to get 5 times 0.75 squared. 5 times 0.75 squared. And this will be equal to 2.81 meters. 2.81 meters.